Hello to everyone and welcome to our cloud coaching event. My name is Violeta. I'll be one of the hosts for this event. So in this session, you will learn how to combine the world of IoT with our managed open source offering on OCI. More about the use case from Piotr, who is our speaker. Piotr, would you like to say a few things about the topic and about yourself?
Sure, absolutely. Thank you, Violeta, for the introduction. So once again, my name is Piotr, and I'm a part of the Open Source Data Platform Specialist team. And today we will be covering the topic of combining, once again, the world of, let's say, IoT microcontrollers with a series of our open source, managed open source services on OCI.
Important note regarding the demo. So all the examples that were used in the demo that we will showcase today were built for showcasing purposes only. So they are not real and they are not showcasing any real workload or use case. That's important. I think that was all on my side. Piotr, over to you.
Thank you very much for the introduction, Violeta. Thanks, Robert, for supporting the chat. So without further ado, let's take a look at how we can combine the world of IoT with some of our managed open source offerings on OCI. With the stars, OCI Streaming, Data Flow, Cache, and Database with PostgreSQL. So looking at the agenda, we'll first take a quick look at solution architecture. We'll break it down component by component, going through the flow from the beginning to the end, meaning going from the edge device itself as far as the end application. We'll discuss some potential use cases, and then we'll also have a look at some potential troubleshooting tips in the interest of perhaps you repeating a similar solution. And then we'll jump to the live demo itself, where we will once again go through the whole architecture and have a look, deeper dive into all of the components that we will be interacting with today. So, oh, sorry, thank you, that's a valid point. There we go. So now that should be better. So that was the agenda. And now let's get into the breakdown itself. So on the left-hand side here, we have the edge architecture. So that is everything that's outside of OCI, starting with the microcontrollers or the devices which are actually delivering the data, going then to the MQTT broker, which serves as the, let's say, orchestrator or as the hub where all of the data is sent to and then consequently delivered to other data sources or is consumed by other data sources. Lastly, we have the Kafka producer that then sends the data from the broker to OCI in this case. And that is where the Oracle Cloud comes into the picture. Firstly, the Kafka producer connects directly to OCI Streaming through the Kafka harness. And then we leverage Data Flow to process that data with structured streaming. So we're able to perform data engineering tasks and consequently load the data into the two respective databases. One being OCI PostgreSQL, where we're storing historical results in this case, and then we have the cache, where we're able to process the real-time information, which are then displayed on the application level. Now, of course, we could have multiple different setups here. Data flow could be simply used to create our standard data lake scenario by saving the, say, Parquet files, Iceberg files directly into object storage. But in this particular case, we're looking to leverage the power of OCI Cache and OCI PostgreSQL. And what I will cover in more detail is precisely how we can handle a high level or a high volume of incoming requests. As we know, with a lot of data, with a lot of edge devices, we could have, let's say, thousands, millions of records coming in every second. So that part will be crucial. So let's start going and breaking down this whole architecture element by element, component by component, and seeing how all of this comes to a single picture. So, architecture breakdown. We're starting off with the microcontroller itself. So what this is an M5 stack microcontroller. It is actually powered by an ESP32 device underneath. If you in the IoT world, you might remember the ESP12 or the ESP8266, which I have personally started my adventure with around 10 years ago. And I can tell you this was not a fun experience, because programming the ESP8266 was a rather frustrating experience due to frequent Wi-Fi connectivity breaks and many other issues with flashing the firmware. However, the ESP32 is truly which you can find across, I would say, practically any sort of IoT device that you can imagine in today's world. It features Bluetooth and Wi-Fi connectivity, so you can make the most of those and leverage the various wireless technologies. It does have a real-time clock in it as well, so if you require some level of precision, that can always go a long way. Additionally, as we are in the topic of a car, right? We are looking at ways so we can measure how the car accelerates, perhaps to understand the pitch, the yaw, the roll of the car. See, for example, if we're to get into an accident, right, and the car rolls, then we are able to retrieve all of those details, all of that telemetry, and that is thanks to the 6-axis IMU that's sitting inside of this device. Last but not least, we have all the additional I/O pins where we can hook up additional sensors, additional devices, for example, something like camera and so on, which we can then process additional information with and push that to our MQTT, for example. So what's great about these things? Well, they're rather easy to program. They're easy to integrate with our current solutions, with our current environment. So if you are looking just to get started, you can, for example, leverage something like the Arduino IDE. And then if you want to go a bit lower, you can, for example, leverage the ESP IDF extension in Visual Studio. So you can kind of go from, I don't want to say low code, but almost low code to low level code. And that is very, very important, as with a modular design, we have essentially infinite use cases. So that's that for the microcontroller itself. Now let's take a look at the MQTT protocol itself. So we're going to look at the publisher first, and the publisher is basically the device, the sensor device in this case, that sends or publishes the message to a specific topic, and then other devices, applications can subscribe to that specific topic, and that is how the messages are then delayed. So we have, let's say, something in the form of a mosquito pub. Then we specify the topic, we specify some host, and then we relay the message itself, breaking it down into these 4 parts where we have the topic, the message, the host, and the command itself. Likewise, once again, we have the subscriber, which listens on a specific topic to which the publisher sends the messages. So there can be multiple subscribers on a topic, which then receive that message as illustrated on the diagram. And the same story here. We have, instead of the pub, we have the sub command and the topic on which we want to listen on. The hash here represents all topics, but of course you can choose a specific topic to listen on. Moving forward, we have the Kafka producer itself. In this case, that data flow is created in Node-RED, so we're able to connect our broker to Node-RED, then parse the data into the Kafka producer, and once again, the Kafka producer is configured with our OCI Streaming Kafka. So that's how we make the connection from, let's say, the edge to the cloud. And we have, once again, the credentials specified, we have the topic specified, and then we can specify the partition, for example. And naturally, we have the key on which we are processing the data. In this case, that's device car. So that gives us the full picture going from the edge to the cloud. And now we're arriving inside of OCI. And naturally, if you are not aware yet, OCI is a great place to run your open source applications. We have a host of managed open source services and solutions, but that's not only it. We are active contributors to many open source projects as well. So if you are not aware of that, you can check it out at opensource.oracle.com. Starting with OCI Streaming. Once again, fully managed, allows you to connect with Kafka, for example, as we've seen. And it is rather inexpensive, as you're only paying for the data streamed and nothing else. And naturally, you can interact with it through REST APIs. Now, going to the data engineering part, we have OCI Data Flow with Apache Spark. Once again, a fully managed service that allows you to do all the data processing that you might need, execute your Python, Java applications, whatever you feel comfortable with. And you have additional options like, once again, structured streaming. You can leverage and connect to your data with interactive queries thanks to the SQL endpoint, and do much more than that. Jumping to the OCI database with PostgreSQL, we have once again the managed service that you are able to scale at ease, but most importantly, you have a highly available setup. And that brings me back to my architecture. So we have, let's say we have a multi-node setup, right? We have all of that data coming in from the stream, and naturally that will put a strain on our primary database where all the writes are being processed. And that is where the read replicas can come in. So instead of just reading and writing to our primary, we can just leave the writes on our primary and then leverage the read replicas to fetch that history of the cars, right? And this way we're offloading the primary database and increasing the performance of the solution. And that is also then naturally why we have the cache. Since the replicas that we're reading from the read replicas, we are then able to have the most up-to-date information for the real-time tracking that's coming from our caching solution. And once again, fully scalable setup, and we can increase the amount of nodes in the cluster as well as their size. So if suddenly we have or we are monitoring a large amount or the amount of cars that are being monitored increases, we are able to scale that node automatically. So that is a great advantage of those managed services, where it really help you in those heavy and high volume workloads. Now, jumping to the use case itself. Starting with real-time monitoring. Naturally, as in this particular example, we can look at traffic monitoring, we can look at logistics monitoring, we can look at airport services monitoring. The use cases here are really endless, whether it's a factory, whether it's a remote location. These let's say sensors, these devices can be leveraged in any terrain, in any place that you might imagine. And we are, in today's world, we're collecting a rather significant amount of data. So having an efficient way to understand that data, transform it, and make sense of it can go a really, really long way. So once again, that's where we are able to aggregate the data, collect its results, and analyze it based on some historical data as well. And with all of that put together, we have additional data points for analysis. What is important is not only those edge devices can be the source of truth here, right? We have perhaps some human input as well. We have other data sources, so we can combine all of these to give us a clear, more holistic picture of what we need, what our customers want, where the traffic in the city is, and the same for the other places where you can leverage monitoring. So the outcomes being then improved decision making. Of course, if we understand what's happening and where, we are able to improve how our process looks like, and naturally engage any additional machine learning algorithms such as anomaly detection. So if something is going wrong, we can detect it at the right point in time. And the scalability cannot be forgotten here as well. If we have a solution that scales, we are able to, without fear, basically ingest more data, connect more edge devices, and expand as we need. Looking at a closer picture of the use case, we can take a look at a smart city. Now, this is already happening in some cities worldwide, and in some cities this is going to happen, but definitely something to be aware of with the growing self-awareness, let's say, of our vehicles, right? We have some standards where it allows vehicles to connect, to communicate with some central hub. And also we're looking at things like vehicle-to-vehicle real-time information. So if we're thinking about autonomous cars, right, and for example, accident prevention and traffic congestion monitoring, we can see how vehicles kind of communicating with each other can give a lot of sense as to how route planning should be done, and perhaps what time you should leave a certain location. And this is really where we are going with this. So we're looking at this kind of mesh of brokers almost, that can send information between each other, and then there's some central party can also have an overview of the city, as an example. As of this year, June or July, if I'm not mistaken, all new cars that are being produced need to have intelligent speed assistance built in, which is essentially a fraction or a part of what this smart city example represents, where the speed of the car will be monitored and compared to what the current speed regulation in the area you are in, and some depending on the speed you're going with, the car will essentially be able to control the maximum speed that you can go at. Just as an example of how the future might look for us. There is different deployment scenarios we can leverage as well for how we connect the edge to the cloud. The first being an MQTT bridge that's hosted on an OCI compute, and that connects to OCI Streaming. This means that we have an MQTT broker in the cloud, which we can connect additional data sources to, which we can leverage for Kafka processing in the cloud. Once again, the ability to connect other MQTT clients, and a bonus is the ability to issue callbacks from within OCI. What this means is that we can, for example, easily interact with our end devices for a purpose of, for example, over-the-air updates. So we are able to issue those callbacks then from within OCI. Now, there is a second option where we just connect directly from the edge to OCI. That is what is being, how the connectivity looks like in this particular example. So the Kafka integration is done in at the edge, and there is no callbacks here. So the drawback is that if we wanted the callbacks to happen, we would have to expose the broker so that we can connect to it from OCI, and that can be the advantage of the first solution. So that is those are the two deployment scenarios that can be considered for connecting MQTT or message queues to OCI. Let's take a look at some of the benefits of IoT now. So most importantly, little processing power is required, which means we can place that device, we can place those sensors in a remote location and leave them there for months and sometimes even years, depending on the efficiency of that device itself. Now, not only it is low power, but also it gives us the scalability aspect, right? Which means we can then have more of these devices placed in, let's say in a closer range, and we're not worried about the maintenance of them if everything is done correctly. Now, once again, the MQTT bridges that we can create between multiple brokers, not only to achieve let's sort of a mesh, but it also gives us high availability should we need that aspect. And once again, if everything is done correctly, we have the option of over-the-air updates then. And that is mostly thanks to technologies like, for example, LoRaWAN or Sigfox, which are basically low power wide area networks that have gained popularity in recent years, and they allow us to communicate from these remote places. And while this particular microcontroller doesn't have support for these, that's an extension that can simply be added on top of those microcontrollers. Once again, that's the modularity aspect. Now, imagine if you combine that with a solution like Growing Edge, which is like your OCI in a remote place, right? So you can really then see the amount of scenarios that are possible, even in the most remote regions that you can imagine. As for the disadvantages, while I'm saying that it is easy to update it, you have to make sure that you know what you're doing in terms of how the architecture has been set up. So if you just place that sensor there without any thought, then it can be quite difficult to get back to it. And then since the messaging is asynchronous, if you do not plan for the scenarios, you might lose some of those messages. Last but not least, it's not secure out of the box, so you have to take care of the bridge-to-bridge communication, ensure that you have SSL there, for example, and as well between the broker and the publishers or the subscribers themselves. So now that we understand the whole flow from the edge to the cloud, let's go through the live demo itself. So now if you bear with me, I will share my okay. And now you should see my browser, and this what you're seeing is precisely Node-RED. So that is the first step of our setup. But before we get to Node-RED, we have to turn on these little guys. So let me just start those up. Now this should take a few seconds. And we have my car and my truck. So these are my two microcontrollers that have been programmed, and both of them can generate traffic, and I'm able to add additional trucks and additional cars here as I want. So let's see what happens if I push the traffic here. You can see it's saying generating traffic, and we can see because debugging here is enabled, we can see how the messages are coming through. Some random generated data, but you can imagine in a real world scenario, this would represent the consequent details, parameters of the vehicle. And I can do the same for the truck itself. I'm not sure if this is visible, but you can see the key here being device truck, and earlier here we saw that it was device car. And once again, you could observe here that the Kafka producer was indeed producing the messages. That means that something is more than likely happening on the OCI side of things. Just to see here, once again, I have my server, that's my broker configured here, subscribing on a specific topic, parsing the string, and once again, I have the client configuration, that is the OCI Streaming connector on this specific topic, some demo fake stream, and the key of the device truck for this specific producer. Okay, so knowing that, let's jump into the OCI console and see what we have here. So we have 3 streams here. I have my demo fake stream and I have my default pool. So let me start with my default pool, as that is where we can find our Kafka connection settings. So if you want to connect to the Kafka server here, that's where you would find those details. Now, jumping back to the stream itself, I have the stream with some read and write throughput. Of course, these values can be adjusted, and I have a retention rate of 48 hours set here. It's blurred out, but you have to take my word for it. So if I press load messages, hopefully there is nothing here. But once again, if I go here, I press traffic, I should start. And you can see how the messages are literally coming here in real time. So that's my device card. Let's see if my truck is working as well. You can see the truck is coming true. So we've made it now from local or the edge network into the cloud. And let's take the next steps. So if we remember, the next step is OCI Data Flow. Okay, so here I have my data flow application. That's my IoT streaming application. I have certain driver and executor shape configured here. I have my Spark configuration properties. I also have private endpoint configured, which means that I'm able to access my databases, my cache and my PostgreSQL that's sitting in the private subnet, through configuring the private endpoint with the required private zone DNS entries, which allows the traffic to go through. I'm using Spark 3.5, which is the latest Spark version available on OCI, and I have my run already started. So the application is based on a piece of Python code that's sitting in object storage, and when I want to initiate the run, it takes the respective configuration that's in the application itself, and then simply runs that piece of code. So I have some additional arguments here as well, which I'm passing to the application itself. So let's take a look at the run itself. So as already mentioned, the run itself reflects the configuration of the application. So the configuration here is exactly the same, but what interests us is the Spark UI here. So I'm able to see my standard Spark UI. We can see we're running 3.5. We can see we are inside the IoT car streaming application. And that's where we can see all the completed jobs, where we can see and drill down through our SQL frames, right? So I'm able to open those, and if I, for example, have a closer look at the details, I can actually see the data model here that I'm working with, right? So I can see, I can recognize all of those fields together with their data types. So if you are, let's say, debugging, if you're trying to understand how an application works, what data it is sending, you can drill down through these, thanks to the Spark UI. And the most important thing, we are leveraging structured streaming here. So I have a run here, and you can see that we are able to monitor the amount of volume, the amount of data that is being passed through the stream. So if I start generating traffic, I'm able to see that the average input per second is changing. If we click into it to see some more details, we're able to precisely see the input rate in records per second and how our solution is performing. So if we were to start inserting millions and thousands of records, that would be a great way to observe how that is performing. Okay, so we've covered streaming. We saw that the data is coming in through. We saw that we have the data flow application, and now we have a place where that data is being saved. So there is some operations happening on the data, and then it is being inserted into two places, right? One being OCI cached, and one being the OCI database with PostgreSQL. So let's just have a quick look at those, starting with my PostgreSQL database. Here I have my multi-node system with one primary and one replica. Once again, the primary is where I am processing all the writes, and then the replica is used to read back the historical logs to offload the primary. We can see all the endpoints here and any relevant information that comes with the PostgreSQL system. So if you want to play around with that, you can give it a go. It's relatively easy to get going. And now let's take a look at the cache. Let's take a look at the cache itself. So this is my Redis cache. I have two nodes here, leveraging Redis 7.0, and I have my primary endpoints and my replica endpoints here as well. If the solution was more intertwined, more complex, we could even then go to the lengths of leveraging the primary and the replica endpoint on the cache itself, especially when our data model is much larger. If we're requiring to, let's say, place different sets of data in different parts of our application, some might need to be refreshed more often, and some might not be as critical, and that's where we can leverage that. So this, as already mentioned previously, this can be easily scaled, so we can easily increase or reduce the amount of nodes, and the same thing can be done with the memory, so that can be scaled. Okay, so we've seen the basis of those services. Now let's take a look at the database itself. So here is the cars table that I have within my PostgreSQL database. It was empty when this demonstration started, but now if I press refresh, I can imagine that it will be filled with some data, and that is precisely the case. So let me do a 1 second refresh on this table, and you can see that I have 60 entries here. So let me start generating some more traffic, and you can see that more entries are being added. Now, what happens if I add some more trucks? We will be able to see that consequently larger amount of data is being added. So now I'm simulating let's say eight trucks in this case, right? And you can see how the data is coming. But let's remember that it is not only the PostgreSQL database here that's working with us. It is also OCI cache. So let me open my console here. I'm connected to the cache cluster here. So let me do keys IoT, and we can see that all of those keys are present here. If I was to inspect one of these keys, for example, let me take a random one. Right, I can see exactly the same information that we previously saw in Node-RED, or that we can see in the PostgreSQL database, and that's the basis of the solution. So you can see just how quickly those results are coming in here as I'm generating additional traffic. So that's the PostgreSQL, and that's the cache. But I also have the application here. So what I have is my let's say backend in Go. So in Go, I'm connecting to my PostgreSQL database. If I just have a look at the piece of code here, so I'm connecting to my Redis and my PostgreSQL database in Go with the Go Redis and the PGX libraries, and then I have a certain data model for the vehicle here, which allows me to easily interact with the data that is coming from the database. Then, what more to add is this Go application then also has the Mux library. So I'm exposing that data as an API, which my front end React application then consumes. On the left-hand side here, that's just a piece of the microcontroller code that's running here. So that's where I'm generating all of the data that you are seeing then in the respective data sources. I won't be going through all of this code, but just to give you an idea of what I'm working with here. Okay, so that's my Go application started. That's my React front end running as well. So now if I go to my React application, hopefully I should be able to see some records here. So let me start adding some more trucks. I'm gonna go wild and add a bunch. And I'm gonna press generate traffic. And you can see I'm now able to monitor a rather large amount of vehicles. You can see the data is being refreshed constantly. So you can imagine the car is driving, right? We're seeing all the different parameters, all the different telemetry that's coming from the car, which we can base our results on. Let me take this from the picture because it looks like So much for talking about battery life, but it seems that I didn't charge this one enough, so it died. But let me turn it back on the side here and continue generating traffic on the other device as well. Just adding a bunch more trucks, generating some more traffic, and we should see that this list will keep on growing. So now we can see we have around 60. We have around 60 cars that we're monitoring. This UI is not perfect, of course, but it's just to give you an idea of how this solution can work. What we're missing here is the history piece. So that's not part of this application, but the idea is that with all of those records persisted in our database, we can have a look back at our specific vehicle, and we are able to make some predictions, be it on fuel usage, be it on, let's say, how, based on the fuel usage and the engine RPM, right? How efficiently someone is driving, let's say. So all of these things can then be made out from those statistics, from those parameters. So once again, we've started at the edge with these devices, generating some data. We're then going through the MQTT broker that's sitting in the edge, that's inserting data that's passing data to the cloud. And then we have our OCI streaming. We have so once again, then we have our OCI streaming. You can see now there's a lot more data coming in through here. We have the data flow application, and then the two databases, the cache and the PostgreSQL database that are taking the data. If I was to go back to my database now, we can see that there is significantly more rows. If I just stop the refresh for a second and keep scrolling, we can see that there's probably around I don't know, 2,000 rows in there by now. So indeed, that those numbers can grow quickly. You can just imagine what happens when you have thousands of cars on the streets and all of those are being monitored. That's a significant amount of data to deal with. Okay, so that takes us through the complete use case. And now if you allow me to go back to the presentation for a second. So let's briefly talk about some troubleshooting options here. Where to look? I would say that most issues might happen around data flow. It can be quite complex to get started with due to the various configurations you have to do, due to, let's say, if you're working in a large team, they might be constantly changing the application, adding new arguments, and so on. So that might be something to watch out for, making sure that you pass all the arguments, making sure that you're using the correct archive zip with all the dependencies that you need for that specific application. And when you are, of course, in troubleshooting, you want to check the relevant logs, as you can see here on the right-hand side, looking at the driver execution, looking at the executor run as well, to understand what's happening in the logs. And some examples of what that is, and you can see based on this application, is, for example, missing the JDBC driver, right? So if you're missing the JDBC driver, you will get Java class not found exception, which is pretty standard error, but then we can see it's the PostgreSQL driver that will tell us that the JDBC driver for PostgreSQL is missing. So once again, if you didn't configure your private endpoint correctly, you will get something like a connection attempt failed, right? And that already happens on the driver level itself. So we're now, okay, we have the driver, we're able to leverage it, but there is some issue with connection. Perhaps the private endpoint is not configured correctly, or we have some issues with the resolution. So that is another point that can be looked at. Thirdly, OCI Streaming has a retention retention time. So if you saw for my stream, that is 48 hours. Now, there is a checkpoint that's present in object storage to ensure that our application can recover seamlessly to a particular offset of the stream. However, if that checkpoint has been created and then we've left the application alone for a long time, obviously that checkpoint is no longer valid. In such cases, either we have to start anew, which means deleting the checkpoint itself, right? Or manually adjusting the configuration. For example, by changing the fail on data loss parameter. So those are some things that you might face while, for example, starting with data flow, and that are worth to look out for, because once you start working with it, it can be truly fun. And the option of integrating the various data sources and also transforming the data, but not only in batch like you've seen in this particular example, but also extending it with machine learning functionalities. Thanks to the possible integration with data science notebooks, can really take your data to the next level. So that kind of completes our use case here. So if you are interested in the topic, you might want to have a look at some useful resources. So we have a GitHub repository. So our open source data platform team has various examples on the managed open source technologies that we're working with. So if you're interested, do check it out. Then once again, if you're keen on open source, you might want to see how and where Oracle is contributing. So do check out opensource.oracle.com. And if you are interested in the technologies that were used in this particular demo, do check out MQTT, Node-RED, Golang, and React. Golang being once again the backend, and React being the front end for this specific demo. And with that, I will pass it back to Violeta. Thank you for your attention, and I hope that you've enjoyed this presentation.
With that, I would like to thank you all for being here with us. Thank you, Piotr, for the great demo and the presentation, and for all your time invested in the cloud coaching event. Thank you, Robert, for assisting us in Q&A. Thank you, team, for being here, Tom, Ettore, and helping as a co-host. We hope that we see you soon at Cloud Coaching. And of course, I would like to wish you to enjoy the rest of the afternoon. Bye-bye. Take care.
Bye-bye. Thank you for having me.